Hello and welcome back to Chapter 13. Today we're going to look at the Part 2 video, and we are going to be looking at what we call the combined gas law. In the Part 1 video, we talked about Boyle's law, Charles' law, and Gay-Lussac's laws. Now what we're going to do is we're going to actually combine them, thus the name combined gas law, into one law. And we can do this because of the unique relationship between pressure, temperature, and volume. So as you can see here on the screen, our combined gas law says P1 V1 over T1 equals P2 V2 over T2. If you notice, this is exactly, if I want like Boyle's law, I can go ahead and see that Boyle's law is just P1 V1 equals P2 V2. If I want to see what Charles's law is, well then I have my V1 over T1 and my V2 over T2. If I want to see what Gay-Lussac's law is, then I can see that I have my P1 over T1 and my P2 over V2. So I personally will only memorize this formula right here because the other three formulas are all based off from this. And if I don't need something, let's say I'm looking at Boyle's law, and I don't need to worry about temperature because it's either not given or I'm told that it's held constant, then I just ignore this piece here and I just deal with the numerator. And that works like that for any of those three. So let's take a look at how we can use this in an example. Example 4 says a gas at 110 kPa and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. If the temp increases to 80 degrees Celsius and the pressure increases to 440 kilopascals, what is the new volume? Now there's a couple key things here that I want you to take note of. First of all, I am given that I have a pressure, so I'm going to call this a P1, a temperature, T1, and I'm given an initial volume, so this here will be my V1. Then after this thing temp increases, I have a second temperature, my pressure increases, so this is going to be my P2, and then I have to find out what my V2 is. So I personally like to go and find out all the pieces of this first of all, because sometimes it will tell me that my temperature is staying constant or my pressure is constant. Something that is constant means it does not change. So even if they give you a numerical value, you can plug it in if you choose, but you also do not have to, because if it's constant, it's going to be the same in both cases. Now with this example, I do have P1, V1, T1, and I'm given P2, T2, but I have to find V2. So in this case, I'm just going to plug this into the formula. Because I have all three parts, P, V, and T, I'm going to use the combined gas law. So with that, we have P1 V1 over T1 equals P2 V2 over T2. Now please remember, and this does not change even with the combined gas law, when I have to find my temperature, I'm actually looking for my Kelvin temperature. So for my T1, I'm given that I have 30 degrees, and I'm going to add that to 273, and that's going to give me 303 Kelvin. My T2 was given to be 80 degrees Celsius, and I'm going to add that to 273, and that's going to give me 353 Kelvin. Now I can take these numbers and plug them into what I have been given. So here I've plugged in my P1, V1, and T1, and I set that equal to my P2, V2 over T2. Now all I have to do is I have to go and solve for my V2 value right here. And I'm going to work this out. If you know how to do that, great, go ahead and solve it on your own. Otherwise, I'm going to work the math out. So I'm going to get rid of my 353. So I'm going to multiply both sides by 353 Kelvin. And then I'll do that over to the left-hand side as well. And what's going to happen then is my 353s are going to cancel. And I'm going to end up with 353 Kelvin times 110 kPa times 2 liters divided by 303 Kelvin equals 440 kPa times my V2. So right away, before I go and simplify one more step, I see that my Kelvin temps are going to cancel. And now, because I'm looking for my volume, I need to cancel out my kPa, or my kilopascals. So I'm going to divide both sides by 440 kPa. And that means I'm going to divide by 440 over on this side too. So again, you can see that the kPa's are going to cancel. My only unit that's going to be left is liters. And when I go and I do the actual math, what I end up with is an answer of V2 being 0.58 liters. And this here is my final answer. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.